I'm Anil Kumar. Welcome to my series on polyhedrons. We'll discuss about polyhedrons and Platonic solids in this particular video. These are the topics of our interest. The very first one is a question: what is a polyhedron? Second, name a solid which is not a polyhedron. Third, explain Euler's formula F plus V minus E equals to 2. Sketch a polyhedron with 8 faces and 12 edges. What is a Platonic solid? A polyhedron has 20 regular hexagons and 12 regular pentagons as faces. Find the number of edges if it has 60 vertices. So let's begin with solving these questions. To give you an idea, polyhedrons are 3D figures something like these shown here. You can actually pause the video, answer these questions, and then look into my suggestions, right? So let's begin with the very first question, the most important, that is to understand what, after all, is a polyhedron, right? So let's answer this. So a polyhedron basically is a 3D shape. So it has few properties. First, it is a 3D solid, right? Second important property which it has is that all the faces are polygons. All the faces are polygons. Okay. Now it is important to note here that there could be different kinds of polygons, or could be different types of polygons, right? But all should be polygons. That is kind of very important, right? Now, then the important thing here is that these faces, they intersect in a line which is called an edge, right? So in a polyhedron, we have edges. And these edges are basically line segments intersection of faces. So the faces of a polyhedron will always intersect into edges, right? And the edges will meet at vertices. So we have vertices also. So as far as the vertices are concerned, the vertices are the points where the faces intersect, right? Or you can say that the edges intersect, right? So we can call vertices are where the edges intersect. So to give you an example, let's take a rectangular shape, right? Now this rectangle is a polygon, right? So if we have a vertex here and we can join this with different vertices, we get a shape here. Now this particular shape is a 3D where we have one face which is rectangular, right? We have one rectangular face. And we have 1, 2, 3, 4. With all those 4 sides and this vertex, we have 4 triangular faces. Now that is a polyhedron because all the faces are polygons, correct? That is a polyhedron. Now these faces, they intersect. So you see these faces, these are the faces. Let me shade the faces first. What we are saying, this is a face, right? Base. This is also a face. These are the faces, which we have mentioned as one rectangular face, which is the base, and 4 triangular faces. And these are the edges. What you see, these are the edges. So this edge is because of these 2 faces intersecting. Do you see that? So we have how many edges? We have 4 at the bottom and 4 going to the vertex. We have 8 edges. Is that clear? Now, these edges, they intersect at some points, and these points are the vertices. Correct? So 1, 2, 3, 4, and 1, 5. So that is how we have a well-defined polyhedron. Now, name of the polyhedron is also based on the face, right? So since it is a rectangular and where everything meets at one point like this, it is a prism. So we'll name this as rectangular prism. So the name of this will be if the other side is congruent to the base, in that case, pyramid. So this is a rectangular pyramid where we have one vertex on the top. Prism will be one in which we'll have the same top as the base, right? Okay. So anyway, this gives you some idea about what a polyhedron is, right? Now the second question over here is, name a solid which is not a polyhedron. Name a solid which is not a polyhedron. So not a polyhedron could be cylinder or even cone. Now these solids, as you can see, this is a cone, right? And then we have a cylinder, which I should draw first. The faces of cylinders and cones are not polygons. You have this circle here, correct? And the curved surface. These are not polygons, right? So the face, circle is not a polygon. So the face, which is circle, is not a polygon, and therefore this is not a polyhedron. Is that clear to you? Correct? So that is how we actually distinguish between these different 3D shapes, right? So we are talking about 3D shapes here. So in 3D shapes, the ones which have polygons as its faces will be called polyhedrons, and if even one of the faces not a polygon, in that case it is not a polyhedron. Perfect? Now let's move on and talk about something very interesting, which is, we talked about what are faces, what are vertices, and what are edges. There is a very good formula, Eulers Formula, which relates these numbers. Number of faces, number of vertices, and number of edges. So when you add number of faces and vertices and take away the edges, you always get a number 2 for a polyhedron. Okay. So let's try to figure this out for the examples which I have taken here. So we'll talk about triangular prism, rectangular prism, hexagonal prism, and then triangular pyramid, pentagonal pyramid. So let us sketch these and then we'll count how many faces, vertices, and edges they have. Triangular prism means we have a triangle here, let's say, right? And prism means exactly similar triangle on the top also, right? So let me just, okay. And then you just combine, join these edges, right? So the shape which you are seeing is called triangular prism, right? Now in this shape, how many faces are there? Top and bottom, right? And then these three triangles, right? So we have 5 faces here, top and bottom 2, and 3 on the sides. Vertices are 1, 2, 3, 4, 5, 6. And the edges 3 and 3, 6 and 3, 9. Do you see that? So that is what we get. Now if you check, face plus vertex is how much? 5 plus 6 is 11, and 11 take away 9 is 2, right? Do you understand? So the formula works here, right? Similarly, what you can do now is just pause the video and fill up this table. So we have rectangular prism. So last time I made a pyramid. Now we'll make a prism. So make a rectangle right here like this. And whenever you're making a prism, just make exactly similar on the top, correct? So we have kind of like this, right? So that is the base. Anyway, I went slightly, I should use different color. Okay. So we'll use a different color and then squeeze it in. Okay. So let me just say that this is, let me just redo it, right? So I'm making it shorter since otherwise it'll mix that up, right? So we have this one, okay? So that is our top, and then when we combine these, you see, right? This is slightly wrong. Anyway, now let's count the faces. Top and bottom, that is 2, and 4 on the sides. So we have 6 faces. Vertices 1, 2, 3, 4, and 4, 8. Edges 4, 4, 8, and 4, 12. Now again, if you do your math, which is adding these 2 is 14, right? And take away 12 is 2. So it works, right? Hexagonal prism means that you have 2 hexagons now, right? So prism means we have 2 hexagons. Let's just make 2 hexagons, right? One on the top, and then we'll make one at the bottom, correct? So this is the side which is on the other side, and we'll just make this. And join these points, right? So you can join these points, which are the vertices. It makes sense, right? Slightly better than before. Hexagonal will have how many faces? Hexagonal faces on top and bottom, 2 hexagonal faces, and 6 of these which are rectangular, right? So we have 8 faces. Vertices, 6 on the top, 6 in the bottom, which makes it 12. Edges, 6 on the top, 6 in the bottom, 12. And those standing vertical is 6 again, so it is 18. When you add 8 and 12, you get 20, and 20 minus 18 is 2. So it works. You get the idea, right? Now we're talking about triangular pyramid. So that was a prism. So let me again sketch a pyramid here. So we have now a triangle here, right? Something like this. And pyramid means we'll just connect it with one point on the top. That's what you get. Now in this case, number of faces is 1 triangle in the base, 3 on the side, all triangles, 4 in all, correct? As far as the vertices are concerned, we have 1, 2, 3 and 1, 4. 4 plus 4 is 8. We are expecting how many edges? 6. That is true. 3 in the bottom and 3 standing. So it works. Do you see that? Now the last one here is pentagonal pyramid, right? So we have to sketch a pentagon. So pentagon will have 5 sides. So we have 1. So let's say 2, 3, 4 and 1, 5. So 5 sides. And pyramid means there'll be only one point on the top, and that gets connected with all of them, right? So let me just take one like this so that, you know, we could actually show you how it looks like. Is it okay? Right. So, something like this. So that is your pentagonal pyramid, which has how many faces? 1 at the bottom, which is pentagon, and then we have all these triangles. So whenever you have a pyramid, we have triangular faces, right? 5 of them. 5 plus 1 is 6. So we have 6 faces in all. As far as the vertices are concerned, 5 plus 1, 6. That makes us 12. We expect 10 edges, right? 5 and 5, 10. That makes sense. Good. In each case, you will find that the number of faces plus number of vertices minus the edges is definitely equal to 2. So I'd like you to calculate, right, these values, right, and then see if you really get 2 for each, right? If you do, then the formula works. Otherwise, you've done a mistake, right? Formula always works for a polyhedron. Okay. Now, we'll talk about sketching a polyhedron with 8 faces and 12 edges. How can we do that? Okay, so important thing here is to figure out how many vertices, right? So let's get back to this formula. Face plus vertex minus edge is 2, right? So we have the formula which is face plus vertex minus edge equals to 2. We are saying to sketch a polyhedron with 8 faces, right? So 8 and 12 edges minus 12, which is 2. So we need to find how many vertices are there. Correct? So let's figure this out. So what number will give me 2 here? So that should be how much? That should be actually 7 or 6. What? Total has to be 14, right? So we expect V to be 6, or you could calculate like this. V equals to 2. Take this 12 on this side, take away 8. Is that correct? So we have 14, and from 14 you take away 8, which gives you 6, either way. So we have 6 vertices. Now, with 6 vertices, you have to sketch a polyhedron which has 8 faces. How will you do that? So I'd like you to pause the video and figure it out. Right? So the solution is something like this. Well, we have 6 vertices. So one is, let's say these are my 4, which I am doing like this. And then we have one on the top and one at the bottom. So what happens really is that we can just combine, let's say this one like this, right? So I purposely shifted it a bit so that, you know, I can clearly show you a drawing. So that becomes the top, right? So we have, do you see that? And this is the bottom part, so something like this. Correct? So that shape has got 8 faces, you can see, 1 common, right? And then 4 up, correct? And we have 4 down, right? So each. So outside, if you're looking at, don't count this thing in between, only these triangular faces, right? So what we have here is we have 8 triangular faces. Correct? Don't count this. These are getting joined, okay? And it is not a face. Think it is hollow from here. Is that okay? So that is not a face. However, it does combine with your edges. I mean, I should have drawn a dotted line, correct? So that is how it is. The number of vertices are clearly 1, 2, 3, 4, 5, and 1, 6. Correct? 6 vertices. And the edges. So as far as the edges are concerned, we have 4 on the top, right? And we have these 4 and 4 in the center. So we have 12 edges, right? So we have 12 edges and we have 6 vertices. Now we'll learn more about this diagram soon, right? But for now, that is the shape which is a polyhedron with 8 faces and 12 edges. Okay? Now, next question. Here are two other questions for you. Question is, a polyhedron has 20 regular hexagons and 12 regular pentagons as faces. Find the number of edges if it has 60 vertices, right? So I'd like you to pause the video and answer this question. So it has some faces which is given to you, right? So F is given to you. And number of edges, find the number of edges, we don't know. Vertices we are given, so we know vertices. V is 60 for us. Faces is 20 plus 12. Do you see that? Which is 32. And we need to find the edges. E. So how will you find edges? Well, again use the same formula, right? So that's a very important formula. Edges are maximum. Remember that. So faces plus vertices, the formula here again is faces plus vertices minus edges equals to 2. We want to find edges. So we can say faces plus vertices minus 2 is edges, correct? So you can add these two and take away 2. That should give you the answer, right? So let's do it. So faces is 32 plus 60 minus 2. So that gives you 30 plus 60 as 90 edges. Do you get it? So the number of edges is 90 for this particular case. Perfect. So that is how we are going to answer this particular question. Now here is another very interesting question, and that is about Platonic solids. What is a Platonic solid? Now that's a very common term, most of the time used whenever we talk about polyhedrons, right? So in a polyhedron, there is a special kind of a polyhedron where we have this is a special polyhedron. So what is special about it? One, we have regular polygons as the faces. Okay, regular means all polygons, like all sides equal, all angles equal. Okay, regular polygons as faces and only one type of polygon. Not combination of two as you saw in pyramids. You see that? So that is kind of very important to understand, right? So that is important. So same number of faces meet at all the vertices, that is also important. Correct? So these are distinguishing features of a Platonic solid, right? So a Platonic solid will always have regular polygons as its faces. All the polygons will be of the same kind, right? So if we have triangular, all will be triangular. If we have pentagonal, all will be pentagonal. That's what it is, right? If we have square, like a cube, right? Cube is a good example. So cube, all are exactly similar polygons, squares, right? And all of them, they meet at same number meets at each face. There are only 5 kinds which we have here, you know. Now what are these 5 kinds? Let's have a look at these. So the next page gives you the figure of these 5 kinds of Platonic solids with their names. So the most basic is tetrahedron. You see all triangular faces in a tetrahedron, right? So we see 4. Tetra means 4. This thing, tetra means 4. 4 tetrahedron, right? So the polygons, the number of polygons here are 4, right? So what we see here is that there are 4 faces. So we have 4 triangular faces. Correct? So that is kind of very important to understand. Now, at each vertex, how many faces intersect? So let's look at this particular vertex, for example. So at this vertex, 3 faces intersect, right? So 3 faces intersect at each vertex. So as we pointed it out, for a Platonic solid, it is very important that all have same polygons, regular polygons, right? And only one type of polygon, and same number of faces meet at each vertex. That is important, right? So what we note here is that there are 3 triangles which will meet at each vertex. Each vertex there are 3 triangles, correct? So that is a tetrahedron. Now cube is also called hexahedron. Hexahedron, since it has 6 faces, right? Hexa means 6, right? So this means 6 faces. So we have 6 square. So that means a regular figure, right? 6 square. And these are triangles, and these triangles are equilateral triangles, okay? 6 square faces. So at each point, as you can see from here, you will note that, let's take this point, right? So 1, 2, and 3 faces meet at each point, correct? 3 faces intersect. Clear? Octahedron is something which we just drew, right? So what we had sketched earlier was actually octahedron. So I hope now you understand the properties of this octahedron. It has triangular faces, right? So octahedron has, as the name suggests, 8 triangular faces, right? Now at each face, at each vertex, let's say this vertex. So how many triangles are meeting at this vertex? 1, 2, 3, and 4. So we have 4 faces meet at each vertex. Is that clear to you, right? So at each vertex, there are 4 faces which are meeting, right? So here, if you consider this one, we have 1, 2, 3, and 4, right? So 4 faces meet at each vertex, and the name is octahedron. The next one, as you can see here, we have pentagonal faces. So we have, actually in this particular case, we have 12 pentagonal faces. Twelve gives it a name, dodecahedron. So that is 12 faces. Each is pentagon. And at each vertex, there are 3 faces meeting, right? So 3 faces meet at each vertex. So when you describe a Platonic solid, these are 2 very important things. What are the type of faces, right? There should be regular polygons. And how many of these meet at the vertex? Correct? Icosahedron is the 5th type, the final, in which we have 20 faces. And each is triangular, as you can see here, right? 20 triangular faces. And at each vertex, 5 faces meet, right? So 5 faces meet at each vertex. So that is how you can describe these 5 Platonic solids. In another part of the video, we'll discuss why there are only 5. Perfect. However, this video gives you good information about polyhedrons and Platonic solids. Feel free to write your comments and suggestions. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.